Here's some homework help on the pages 333 and 337. So I just selected certain problems. Here's number 2, page 333. Our directions say to use the rational root theorem to list all possible rational roots for each polynomial equation. So that's the first sentence of the instructions. So remember, the rational root theorem says that we need to list the factors of the constant. That in this case is -6. So let's do that first. Plus minus 1, plus minus 2, plus minus 3, and plus minus 6. Those are the factors of the constant, and the rational root theorem says to put those factors over the factors of the lead coefficient, which in this case is positive 1. So the factors of 1 are just positive and -1. So the answer to the first sentence, like answer part A, would be these 8 numbers. These are all the possible rational roots of this function or equation. Now, the directions say to find any actual rational roots. Well, I tried to emphasize in class, I want you to find more than just rational roots. I want you to find all roots. So we're going to use these numbers in a table. You notice that our pattern that we talked about in class does not hold true in this particular equation, but I'll just refresh your memory a little bit. The pattern is if you can multiply these coefficients, 1 times 4 times 1, and if the product of those 3 numbers would equal the constant, then that makes finding the rational 0 pretty easy. It would just be the opposite of whatever's in front of x squared. But we don't have that pattern here in this case. So we're going to have to use the table that we talked about in class, using these possible rational roots down the side of our table. And then across the top of our table, just like you did with synthetic division, you're going to list the coefficients and the constant. Let me get rid of this since we already know what our possible rational roots are. I'll erase that denominator. So 1, 4, 1, and -6. And now we go through the synthetic division process. You bring down the 1, multiply to your left. 1 times 1 is 1, and then you add 1 plus 4 is 5. Multiply 5 times 1, that's 5. Add, that gives you 6. 6 times 1 is 6, plus -6 is 0. It's always nice when we come up with the rational root right off the top. Our very first number gave us a 0 remainder. So of the 3 solutions or roots that we're looking for, one of them will be the number 1. Well, I'm going to use these numbers to the right. I don't need to keep going through the table. I could, but I don't think it's necessary because these numbers to the right represent an equation. Okay, remember in synthetic division, this is a remainder, this is a constant, this is a linear coefficient, and this is a quadratic coefficient. So if we let these numbers represent a polynomial equation, it would look like this: 1x squared plus 5x plus 6 equals 0. And recognizing this equation, factors, makes it pretty nice. We don't have to use the quadratic formula. I mean, you could if you want to, but if factoring is possible, that's what I prefer. There are factors of +6 that add up to +5, and that would be 3 and 2. Okay, so letting each factor equal 0 and solving, we would get x is -3 and x is -2. So here are my 3 solutions for this cubic polynomial. We got 1 as right off the beginning of using our synthetic division process to go along with -3 and -2. And don't forget, in problems 1 through 6, you're also supposed to list all of the possible rational roots, and that's what we did at the beginning. Okay, so there's your final answer for number 2. Let's take a look at number 5. Once again, let's go ahead and take care of all the possible rational roots. So let's list the factors of negative 16. That's plus minus 1, plus minus 2, plus minus 4, plus minus 8, plus minus 16. Okay, we get them all? Looks like we did. All right, and now let's take a look at this equation and see if that pattern exists. Remember, the pattern is if you can multiply the coefficients together and they equal the constant, then that's good. That saves us a lot of time in searching for the rational 0. 1 times 2 times negative 8 does equal negative 16. So in my table, the only number I'm going to use in my synthetic division test is negative 2. Okay? So one more time, the pattern says if you can multiply the coefficients together and it equals the constant, then you have a rational 0 or a rational solution, and it will be the opposite of whatever's in front of x squared. All right? So let's just go ahead and do synthetic division using that number. All right, there's my coefficients and constant. So let's see what we get. Bring down the 1, multiply, negative 2 plus 2 is 0. Multiply, that's 0 plus negative 8. Multiply, that's positive 16 plus negative 16 is 0. So we know negative 2 is one of our 3 solutions, and we'll get the other 2 solutions from this equation that is represented by these numbers. X squared minus 8 equals 0. Notice the linear coefficient being 0 means we don't have an x term. All right, just solve this equation for x. Add 8 to both sides and a square root of both sides. Don't forget that, and don't forget plus minus because, again, we're looking for 2 solutions. And just write your answers here in simplified radical form. And so my answer altogether, my 3 answers are positive 2 root 2, negative 2 root 2, and negative 2. So that would be the answer for number 5. There's my list, and then here are my actual roots. Number 6, I mentioned this, try to give you a heads up in class. Remember that if factoring is possible, then you really don't want to use the table. I mean, you can, and you'll get the answer, but I think it takes more time and effort than is necessary if factoring can be done. So we want to really just resort to the table and synthetic division and the rational root test only if you cannot factor. So let's answer that first sentence. What are the possible rational roots? Well, let's list the factors of negative 15. Plus minus 1, plus minus 3, plus minus 5, plus minus 15. So that answers that first sentence. And then notice that this is much like you did in the previous section. We can factor this. This is a quartic trinomial, and I'm recognizing that the factors of negative 15 that add up to positive 2 are positive 5 and negative 3. So I can factor this as 2 quadratic binomials. So hopefully this looks familiar. You did some of these last night on the section 6.4 homework. All right. So x squared plus 5 and x squared minus 3 represents the factoring. Okay. Now to solve, you just think of each of these factors equaling 0 and solve them individually. Okay, so over here we get x squared equals negative 5, so x will be plus minus I square root of 5. Over here we get x squared equals positive 3, so x is going to be plus minus the square root of 3. So we started out looking for 4 solutions. 2 of them are here. positive I root 5 and negative I root 5, and then the other two are here, positive square root of 3 and negative square root of 3. All right, so that takes care of my examples for page 333. Now let's shift over to page 337 and do a few of these. Same idea. The only difference here, I guess, is we're not told to list all possible rational roots. We're just finding all the zeros. Now, remember, finding zeros is really the same thing as finding the roots or the solutions. Let's check the pattern and see if it exists. Doesn't look like it does, because 1 times negative 5 times positive 5 does not equal negative 4. So we're going to have to use our table. The possible rational roots will be the factors of negative 4. That's 1 and negative 1, 2, negative 2, 4, and negative 4. And then across the top, we'll do 1, negative 5, positive 5, and negative 4. Okay, well, let's go through our process. So bring down the 1, multiply, and then add, multiply, add, and at this point I know I'm not going to get a 0, so I'm just going to go down to the next number, multiply negative 1 plus negative 5, multiply 6 plus 5, that's not 0, so let's try the next one, 2 plus negative 5, negative 6 plus 5, that's not going to work, negative 2 plus negative 5, 14 plus 5, that's not going to work, 4 plus negative 5 is negative 1, negative 4 plus 5 is 1, 4 plus negative 4 is 0. We found the winner. One of our 3 solutions is the number 4. So the numbers to the right of 4 represent a quadratic equation. And it looks like this: 1x squared minus 1x plus 1. And unfortunately, we can't factor this, so we're going to have to use the quadratic formula. The opposite of b plus minus the square root of b squared minus 4ac all over 2. And we end up with I square root of 3 all over 2. So what I've circled here represents 2 solutions because of plus minus. And the other solution is the rational number 4. All right. Very good. That takes care of number 11. So let's take a look at number 15. Do you notice anything here? You should be on the lookout for possibilities of factoring, because factoring will keep you from having to use the table. And with factoring, it always begins with the GCF. You should always look for a GCF first. And I notice that there is a GCF here in this function, and it's x. So if I factor out x, I'm left with x squared minus 3x minus 9. Okay? So that makes it a little bit easier. At least I know what one of the 3 zeros will be. One of my 3 solutions will be 0 for this factor. Now I'm looking at this factor. It's a quadratic. Letting it equal 0, it would be great if it factored, but it doesn't. So once again, I'm left with the quadratic formula to solve this. Opposite of b plus minus square root of b squared minus 4 times 1 times negative 9. And all of this goes over 2. So we'll simplify the radical. That's the square root of 45 over 2. Okay, and now let's simplify the square root of 45. That's like the square root of 9, which is 3, times the square root of 5. And we always want to check to see if we can reduce this fraction, but we can't, besides 1, divide into 2 and 3 evenly. So looks like that's it. we got 0 as one of our solutions, and then this would be the other 2 to make up a total of 3. All right, so far so good. Looks like this is going to be the last one. Let's go down to number 25 on page 337. And can't do any factoring here. This is polynomial. Your factoring is pretty much going to be limited to trinomials or binomials. But I do notice the good old pattern does hold true here. Okay, let's take a look. 1 times negative 1/2, that is negative 1/2, times 20 is negative 10. That's very nice, because when I set up my table, I'm only going to need to put one number to use in my test, and that's going to be the opposite of whatever's in front of x squared. Okay, so let's list the coefficients and the constant across the top. Bring down the first number. Multiply, that's 1/2. Add, 1/2 plus negative 1/2 is 0. Multiply, that's 0 plus 20 is 20. Multiply, 20 times 1/2 is 10. 10 plus negative 10 is 0. So we know 1/2 is one of our zeros. Let's find the other 2. So these numbers represent an equation. X squared plus 20 equals 0. X squared is negative 20. X is plus minus the square root of negative 20. So we need to simplify that radical. And for those people that are still struggling a little bit with simplifying radicals like this, let's use factors. Let's use these 3 radicals to represent the square root of negative 20. 2 of these radicals we can simplify, because the square root of 4 is 2, the square root of negative 1 is I, and then we're left with this radical that cannot be simplified. All right, and so that should be your answer for number 25. You get 1/2 as the rational 0, and then you've got these 2 complex zeros, positive and negative, 2i square root of 5. Okay, so that's your answer for number 25. Well, I hope that helps you. That's a few of your homework, but maybe I'm hoping that by doing these, it will help you with the rest. But if you still need help, you can always come and see me at Academic Support, and we'll check these out tomorrow.